Hello everyone. So recently I've came across this interesting video language model by Hugging Face that is the smallest VLM out there, and it's called Small VLM2. Now what's interesting is that it was designed so that you can run it on edge devices. So for example, you can build an iPhone app that runs the model on the device without the need for an API. So in this video, I wanted to show you how you can run it, but most importantly, how you can fine-tune it on custom tasks, either locally or for free on Colab or Kaggle. So without further ado, let's get started. Alright, so here we have the model card for the smallest version of the small VLM2 models on Hugging Face. And as you can see here, we can run it with only 1.38 gigabytes of VRAM. So given the compactness of this model, it's naturally more suitable for light and simple tasks. It is not designed for the kind of heavy lifting that requires a lot of processing power. As for the input, this model can process text with one or multiple images, and videos of course. It is also indicated here that the text and media files can be mixed in any order. Then we can find here the evaluation of the model on 3 benchmarks. So the results, as you can see, are average in general, but given the size of these models, I would say it's pretty decent. Now, to use the model, we can follow the usual steps from loading the model and the processor to preparing the prompt with the chat template and generating the response. And here we have the different prompt template to run the model for video inference and also for multi-image interleaved inference. And as I said, you can arrange the media and the text in any order you want in the chat template. Then down here we have the training data repartition. So as we can see, most of the data are videos and images with less amount of text and multi-images. And the reason for that is that they adopted a data mixture learnings approach, as indicated in this blog post up here. So this approach was published in the Apollo paper by Meta, and what we're talking about is in this paragraph, training video encoders. So first they discuss the difference between image LLMs and video LLMs. And to find the best data combination for training, they conducted several experiments with different mixtures of data, as shown here. And as you can see, the best performing ones are the mixtures of data with higher percentage of videos, whereas in case the majority of data are images or text or multiple images, the performance was below average. Alright. So as for the model architecture, let's go back to the models card. It is trained with SIGLIP as the image encoder and small LM2 as text decoder. Now at the top we can see that this model architecture is based on IDFX3, and if you don't know what's that, it's actually a VLM by Hugging Face M4. And here in the model card we can see that it is built on top of SIGLIP and Llama 3.18 billion. And in the IDFX3 paper we can see that it has a modular architecture as shown here. So the visual encoding is done separately from the text encoding, and then the visual features are projected into the LLM input space. Alright, now returning to the small VLM2 model card. Here we have a blog page about this model that shows more details. So they have developed this model to make VLMs accessible on edge devices. This family of models are MLX ready, meaning that they are compatible with the MLX machine learning framework for Apple Silicon chips, like the M series for MacBooks and the A series for iPhone. So basically, as I said, you can build an iPhone app that runs these models on device. And down here they included a demo for the 500 million parameter model running on an iPhone. Now let's go back up here to see the performance of this model compared to a few other VLMs on the MME benchmark. And as you can see, the 500 million and 2 billion parameter models performs relatively close to competing models while requiring much less VRAM. Now we've seen how to run the model with the Transformers library, and here they provided the commands needed to run the models in inference mode with MLX and Swift MLX. Alright, so let me show you now how you can fine-tune this model. Now they provided a Colab notebook to do so, but I will show you the few changes you need to make to run it with the free GPU on the smallest model, and also how to fine-tune even the 2 billion parameter model on Kaggle for free using LoRa or QLoRa. So you can get the notebook from here, or you can find the modified notebooks through the links in the description. So let's head over to Google Colab. And here we have the notebook. So the first thing I want to note is that the notebook by default uses flash attention. However, that requires an Ampere or Hopper GPU architecture, which is not available in the T4 free GPU. So we won't be using flash attention for that matter. So the first thing, let's change the runtime to use the T4 GPU. Then we need to install a few libraries. Now I prefer using weights and biases instead of TensorBoard, so let me remove it from here. And then we need to add the upgrade flag to get the latest version from these libraries. Now let's run these two cells. Then we don't need the flash attention, so let's comment this line. Next, you can connect to Hugging Face if you want to push the fine-tuned model to the hub after training. And for that, you need the token that you can get from your Hugging Face account. Then we have here the different fine-tuning options. Here we have LoRa, QLoRa, and small. So the small variables indicates whether to use the 500 million parameter model or the 2 billion model. And then you can choose either to use LoRa or QLoRa. Now on Colab, if you're trying to fine-tune the 2 billion parameters model, you can't use LoRa because you will get an out-of-memory error. So for example, let's set small to true, and then we will use QLoRa. Then we get the model processor, and we set the LoRa config. And of course, when using QLoRa, we need the quantization configuration from bits and bytes. And then we load the model using the auto model from image text to text. And here we pass the quantization parameters and the model ID, etc. Now we need to comment out this attention implementation parameter because we're not using that. And then down here we also need to remove that same parameter, and we can run this cell. Now we will load the dataset and pre-process it. So we're using this video feedback dataset. Then we perform a test and train split, and we get the train split to use for training, and we can delete the other splits. And here we can see an example from our training dataset. So we have this video, and this is the caption for this video. Next we have here the collating function. So this function would apply the prompt template to have both the videos and caption in the same prompt so that the model can use. And then the formatted prompts and videos are passed to the processor to process both. And this function would return a dictionary which contains the inputs IDs, the attention mask with the labels, and the pixel values for the processed video. So now that we have the dataset, let's initialize the trainer and trainer arguments. As for the training arguments, you can leave them as they are. The only change I will make is this report to parameter. So I'll set it to weights and biases. And let's remove this hub model ID since I'm not pushing the model to the Hugging Face hub. And now we have everything ready, so we set the trainer and we start training. So let me show you here a few training runs that I've made on Colab and Kaggle. So here we have the training run for the 500 million parameter model. So as you can see, the training loss is decreasing, and this model was trained for one epoch, so we have 1000 steps using a batch size of 2. And then we have here the training run for the 2 billion parameter model using QLoRa. So as you can see, we've trained for one epoch as well, and you can see the evolution of the training loss. Now, as for the runs on Kaggle, since we have two GPUs of 16 GB of VRAM that we can use, you can train or fine-tune the 2 billion parameter model using LoRa. And as you can see here, we have the run for one epoch, and here I've used a batch size of 1, so we have 2k steps, and you can see the evolution of the training loss. And of course you can run the fine-tuning with QLoRa, so here we have the run with QLoRa and with a higher batch size. Alright, so here we have the training on Colab already begun. Now if we were able to use flash attention, that would be much faster. Now one more thing I wanted to note before we wrap this up. So here we have the notebook on Kaggle, and when running the fine-tuning of the 2 billion parameter model with LoRa, you may get a runtime error stating that there is a D-type mismatch between the image hidden states and the image embeds. So to solve that, you need to explicitly set the D-type for the model to be float16. So just after selecting the training options, you can add this line of code, and as you can see, that would solve the problem, and you'd be able to run the notebook without any errors. Alright, so that's it for this video. I hope that you found it interesting and informative, and see you in the next one.